Hello and welcome to the makeup lab for the second lab in Unit 5 called Single Displacement Reactions. Purpose. In nature, elements can occur either free, meaning uncombined with other elements, or chemically combined in a compound. The tendency of a particular element to combine with other substances is a measure of the activity of that element. The more active an element is, the more likely it is to combine. In a single displacement reaction, an uncombined element replaces a less active element that is combined in a chemical compound. The less active element is then freed from that compound. For example, in the reaction zinc plus copper 2 sulfate yields zinc 2 sulfate plus copper. The zinc has been replaced by the copper, which was less active, and combined with the sulfate anion, freeing the copper in the compound. Notice copper is by itself on the product side of the equation. In this investigation, you will observe how various metal samples undergo single displacement reactions when placed in an acid. If the metal is more active than the hydrogen in the acid, it will replace the hydrogen, and hydrogen gas will be released in the form of bubbles. Description of setup. You will have 5 test tubes set up on a rack, one for each metal sample. You will combine the hydrochloric acid with each metal and observe the results. The metal samples will be available at the front desk. Be sure to dispose of the metal samples properly at the conclusion of the lab. Well, we do have the setup right here. As you can see, we do have 5 test tubes. 1, 2, 3, 4, and 5. And then those test tubes are going to be holding the metals in the same order that they're presented on the lab sheet on the second side. So looking at the data table in the lab sheet, from left to right, the test tubes will contain zinc, copper, aluminum, iron, and magnesium. Starting out, we're going to get a piece of zinc. Zinc is an irregularly shaped metal. This one is kind of a little bit porous. It's almost like almost like a rock-looking shape, just like that, and then kind of silvery-ish. Not very shiny at all, though. But I'm going to place that in the first test tube. The next one is the copper. The copper is almost like a little BB, little kind of bronze brownish kind of pellet. So I'm going to drop that into the HCl. The next one's aluminum. The aluminum here used just simple aluminum foil, just kind of smushed a little bit. So drop that in there. That one didn't sink, so I'll just give it a little shaking. So then it's dropped to the bottom there. And the next one we have the iron. The iron is granular. It's almost like dirt. So then I'm going to get a little bit of this iron on this scoop, like that, and just drop it into the test tube. And it sinks to the bottom. The last metal that's going in is magnesium. The magnesium is just a thin ribbon. So just almost like a ribbon that would be on a balloon or something like that. So I'll drop that into the hydrochloric acid in the test tube, give that a little shake as well. Then let's see what's going on with the metal samples. Well, the first one was our zinc. And we can see with the zinc here that we have bubbling occurring there in the reaction itself. So then trying to get a good level for focus, here you can see the bubbles that are clinging to that zinc metal, and those bubbles are actually floating up a little bit. So we kind of have a pretty strong reaction here. We definitely see those bubbles. So please record bubbles under your observations for the ZN. We also want to kind of see if there's any heat evolving. I don't feel any heat quite yet, but I will kind of run through a second time. Looking at copper. Copper, I don't see the same thing that I saw with the zinc. But the procedure does say wait at least 5 minutes. The aluminum. Don't see anything going on with the aluminum quite yet, really actively, so we'll come back to the aluminum. And then we have iron. Iron, I'm seeing something in the iron. It's hard to see though. See if I can get a contrasting background. There's this paper here. So then with the iron, it's kind of hard to see that. But what I'm seeing is very small bubbles. I kind of see them clinging to the test tube here. You can kind of make out those little dots. Those are small bubbles. Looks like they clinged there. And then small bubbles are kind of creeping up as I rotate the test tube a little bit. Some of those bubbles are getting freed. Really difficult to see. You may see some based on the quality there, maybe not though. Slight bubbling, very, very little, but right bubbles for Fe. Well, look at this, the magnesium, the last one we did, this one's moving pretty fast. So I hear the fizzing that's occurring. The magnesium is up at the top. You can kind of see that bubbling action. So in talking about the other test tubes, this one here has gone through the reaction process and is near completed in terms of its reaction. And actually, it just stopped. Whoa, this one is considerably warmer than it started out. Started out at room temperature, but putting it against my hand, I definitely feel heat. So please, in addition to the bubbles for magnesium, record that the temperature increased. Heat was released, in other words. Let's check the same thing for the zinc reaction, still going strong. I detect a temperature increase. It's not as hot as that magnesium, but a definite temperature increase on the zinc. So heat with the zinc. Copper still looks the same right now. Looking at the aluminum, I actually see a little bit of bubbles forming on the aluminum foil itself. And that's why it's floating. The aluminum foil kind of sunk at the beginning. So then, maybe knocking it off, you can kind of see a few of the bubbles there kind of clinging to the edge. Hard to make them out, but they're definitely there. So the aluminum, although slow, is reacting. No appreciable heat coming off the aluminum. Still feels like it's at room temperature. Shaking it off completely, still kind of floating a little bit. Just microscopic little bubbles clinging to that surface. Looking again at the iron one, you can see a difference there. Oh, there's some bubbles that are floating to the top as I rotated that iron dirt around. You can kind of see them here on that top edge. So definite bubbles there. No heat for the iron. That leaves the copper. The copper, this metal is not more active than the hydrogen. So copper, actually, there is no reaction. So put no reaction for copper, in that it does not react with the hydrochloric acid. So bubbles were seen for the zinc, the aluminum, the iron, and the magnesium. Heat was noticed for the magnesium especially, but also for the zinc. No heat for the iron nor the aluminum, but bubbles, although slow in their formation and small, did occur. And that completes the video for the makeup for the lab single displacement reactions. Be sure to address the analysis of data and the conclusion before turning in your lab. Thank you.